Welcome to the Master of the NEC podcast, the ultimate destination for anyone passionate about the electrical trade. Whether you're a seasoned electrician, an eager apprentice, or just someone who wants to dive deep into the world of electrical work, you've come to the right place. Join your host, Paul Abernathy, a true authority in the industry with over 38 years of trade experience, as he electrifies your mind with in-depth discussions, expert tips, and valuable insights that will keep you ahead of the curve. Each episode, Paul will illuminate the complexities of the trade, decode the National Electrical Code, and share the latest industry trends, all while empowering you to take your electrical career to the next level. So, gear up, plug in, and get ready to supercharge your knowledge, because with the Master of the NEC podcast, the power is in your hands. Now get ready. Here is your host, Paul Abernathy.
What up, everybody? Welcome to another episode of Mastering the NEC. My name is Paul Abernathy. Thank you for joining me on today's podcast. So on today's podcast, we're going to talk about voltage drop a little bit. There's been a lot of discussion about voltage drop on social media. Obviously, people have been talking about voltage drop for years. People do questions about voltage drop. It appears on electrical exams. Educators, we teach the formula for voltage drop. And so I figured I'd talk a little bit about it because we also get many people who think that voltage drop in residential, for example, is a requirement. And for residential, it's never a requirement. First of all, the only two locations within the National Electrical Code first that we'll talk about is when we have to require voltage drop for sensitive electronic equipment. Okay, so that would be the first application. So if you're dealing with sensitive electronic equipment, then you're going to have a requirement to deal with that. So if you have your code book, and I know you do, if you probably have it handy, that'd be Article 647. And in 647, you're going to see that there's a voltage drop requirement under 647.4D. Now that talks about the voltage drop on any branch circuit not to exceed 1.5%. And then the combined voltage drop of a feeder and branch circuit conductor shall not exceed 2.5%. That is only having to do with sensitive electronic equipment. Now, unlike electrical distribution systems that, supply the lighting and the appliances and those type of branch circuits, that's different because here in 647, the voltage drop requirement is mandatory. In those other areas of the code that we're going to look at under 210.19, for example, is not a mandatory rule. It may be good design, but it's not mandatory. However, the rules for sensitive electronic equipment in 647.4D, that is a requirement if you're dealing with it. So if you have an application where you're dealing with sensitive electronic equipment, the scope of that is this article covers the installation and wiring of separately derived systems operating at 120 volts line to line and 60 volts to ground for sensitive electronic equipment. That's what this scope is in Article 647. If that's what you've got, then you have a mandatory sensitive electronic equipment. You have a mandatory voltage drop requirement. Okay? Now, the only other mandatory requirement for voltage drop is y'all all are probably aware of this when it comes to fire pumps. And that's 695.7. And that is a little different. In that one, it's talking about like from motor starting, it says unless specified in 695.7B or C are met, the voltage at the fire pump controller line terminal shall not drop more than 15% below the normal controller rated voltage. Under motor starting conditions. So start the motor, you have the actual voltage rating that's stamped on the controller. You're falling within that range. You immediately try to start the fire pump and the voltage cannot drop below 15% below that normal controller rated voltage. Okay. Now, where do we get that? That information actually is extracted straight out of NFPA 20. Under Section 9, Subdivision 4.1. So it comes out of NFPA 20 and gets regurgitated over here into fire pumps for voltage drop. Now, that's for starting motors. When it's motors running, then you have another requirement, and that one says the voltage at the contactor load terminals to which the motor is connected shall not drop more than 5% below the voltage rating of the motor when the motor is operating at 115% of the full load current rating of the motor. That also comes out of NFPA 20, and that is 9.4.4. So those are the two locations where, and you really as an electrician, I mean, that's not going to be residential. None of that's going to be residential. It's always going to be commercial for that stuff. And then, of course, most of the time when you're dealing with the fire pump or even sensitive electronic equipment, you got some kind of engineering design involved, and you're hoping that they have already taken all this into consideration in their design. You hope that. Should not be my responsibility as the electrician if I'm just installing and I'm not designing the system, okay? But again, it behooves the electrician to fully understand how that works so that you can kind of be another set of eyes on the situation in case somebody dropped the ball somewhere. Now, if we talk just residential, the only time that voltage drop will creep into a discussion in residential applications is when we're looking at 210.19. And it's an informational note that's under the minimum ampacity and size of a conductor. Okay? And the informational note says, conductors for branch circuits as defined in Article 100, size to prevent a voltage drop exceeding 3% at the farthest outlet of power, heating, and lighting loads, or a combination of such loads, and where the maximum total voltage drop on both the feeders and the branch circuits to the farthest outlet does not exceed 5%. 5%. And that says provides reasonable efficiency of operation. Okay. And it also, by the way, says the exact same thing in 215.2A2. So for branch circuits, for feeder circuits. Now, the thing about this is under an informational note. So it's just really good information. At no point in a residential application are you going to be required to meet this stuff. And if a jurisdiction tries to push this on you, you got to remind them that informational notes are not enforceable. And they go, well, it's enforceable in my jurisdiction. Well, then you've got to push back, right? Because you have to push back and have them understand the rules. And the rules are all given to us in Article 90, right? And it makes it clear under 90.3, which is the code arrangement, lets us know that chapters 1 through 4 apply generally throughout all electrical installations. And of course, you got 5, 6, and 7, which supplement or modify chapters 1 through 7. And of course, you got 8, which is standalone communications. And of course, you have chapter 9, which is applicable when it's referenced. And of course, the informative annexes are just information, just like an informational note. They're just there for good information, like informative annex C when it comes to raceway fill. Okay, that's just good information. You can get there by actually doing the calculation, but the informative annex C kind of gets you there, and it's based on the 40% fill for over 2 conductors. Okay, so you get there that way. But kind of how the structure goes. Now, but if you look at the beginning of 90.3, it'll tell you. It says informative annexes are not part of the requirements for the code, but are included for informational purposes, right? Now, to find out where the informational note comes in, then we have to look at 90.5, which talks about mandatory rules, permissive rules, and explanatory material. And item number C is explanatory material, and it makes it very clear that it says explanatory materials such as references to other standards, like we talked about NFPA 20 for the fire pumps and things like that. It says references to other standards, references to related sections of this code, or information related to a code rule is included in this code in the form of an informational note or an informative annex like we just talked about, okay? So they are not enforceable because it goes on to say such notes are informational only and are not enforceable as requirements of this code. They may be great information and they may give you a lot of guidance in how you work through the NEC, and maybe it kind of reminds you of a certain place you need to be. But at the end of the day, that's all it is. It's just information, great information. to help guide you a little bit. But it's not enforceable. So they can't enforce voltage drop on you in a residential application at all. Now, is it a good design practice? Yes. But there's really not much in a residence, be honest with you, that's going to really push a voltage drop issue. Now, I've done here's where I do have a problem. I have seen, and I have been on the case of a very large home in Oklahoma. And when you start having voltage drop, although it's not a requirement in the code, but you have really, really long runs because let's say they designed it, in my opinion, poorly, instead of having some remote distribution panels, or some people like to say sub panels, positioned around the large dwelling, then you could have a 12.2 or 14.2 that literally run 250 feet before it gets to one part of the dwelling. I've seen it. I've just recently was on a case in Oklahoma about this, and I served as expert witness for it, where you had circuits acting up, causing AFCI devices to trip, and without even having any loads on it. There was no case to neutral connections. It's just, I believe, and again, this is just my belief because I didn't test it, but I believe that voltage drop in distance could have a problem with some of these devices. I can't quantify that. I can't tell you I've done the testing for that, but how I can kind of get there is when I go look at 210.12 and I look at the different locations, and then I go down and I look at, okay, what are the options, the 6 options that I have? If you look at 2 of the options, it's limiting the conductors. If it's 14 gauge, it's limited to 50 feet. If it's 12, it's limiting it to 70. I get it. These are listed supplemental arc protective circuit breakers in conjunction with a outlet style AFCI. But you see what I'm saying? There seems to be some limitation here on the length. And then when you get down, the same thing happens if you have a listed outlet branch circuit type AFCI installed on a branch circuit at the first outlet point, and you use it with a listed branch circuit overcurrent protected device. So that basically they have to be evaluated as a combination. Okay, you just can't take a regular circuit breaker and just pick a regular AFCI receptacle device and consider them a combination. No, they would have to be evaluated together. But my point is, if you look at the rules there for this, you'll see that there is length limitations. They're limiting the length of these conductors, 14 gauge and 12 gauge. So I am a bit dubious of this. So, I have asked manufacturers of AFCIs. I've emailed them. I have people I know. I ask them and I'm saying, look, in your code, in the code, it does not give a length limitation on AFCI devices. How far can I run that branch circuit before I run a potential for voltage drop, and will it affect the AFCI's operation? If the answer to that is no, then answer me why we have a limitation on the other ones, okay? Why do we have a limitation on 210.12 A3 and A4? Why are we limited in those, but we're not limited in the other? I don't know. It's just a hypothesis I have. My point is this. There's nothing right now in the National Electrical Code or even the IECC Energy Conservation Code. There is nothing in there specifically for residential application that would be something that you can sink your teeth into to say, you know what, voltage drop needs to be taken into consideration. All right. Other than the fact that it's just made an informational note that's recommending it. That's it. But that changes, folks, when you get to other than residential. And that's kind of weird for people because they're like, all right, so anywhere else in the code other than single family dwellings and things like that, then we have other provisions that are going to kick in and require a voltage drop to be a consideration. So if you happen to have a copy, you may or may not, it's actually free. You can go online and look at a digital version free of the International Conservation Code. So I'm looking at the 2021 IECC, the June 24th edition, and I'm looking at it. And one of the things that you have to take into consideration is that when you look at it, there is a specific section in here that is labeled voltage drop. Remember, this is an energy conservation code. So if the IECC is adopted in your area and they are utilizing it and that type of thing, then you have to be aware of the voltage drop requirement that's in C405.10. And it says voltage drop, and here's what it says. It says the total voltage drop across the combination of customer-owned service conductors, feeder conductors, and branch circuit conductors shall not exceed 5%. Okay? So the voltage drop, so whether you're dealing with feeder, you're dealing with service, or you're dealing with the branch circuit, what you're dealing with is the total overall voltage drop across the combination of those cannot be more than 5%. Now that's in the IECC. So that's going to apply to where? That's going to apply to commercial because that's under the commercial portion of the IECC. There is nothing like this under the residential portion. There is under the commercial. At least I'm not aware of anything under the residential, and I've looked at it. So with that in mind, if you think about it, if they're enforcing the IECC in your jurisdiction, and it may be that the building inspector is the one that's enforcing this, they're not really savvy in understanding voltage drop, right? They don't understand it. They don't understand electrical unless they're a combination guy or gal. So at the end of the day, there's a good probability that in a commercial building, that they don't even understand that C405.10 is even here. That's a voltage drop requirements in place. And you notice it doesn't say anything about 3%. It's an overall 5. Okay, so anything, it's basically says the total voltage drop across the combination of customer-owned service conductors, feeder conductors, and branch circuit conductors shall not exceed 5%. Okay, so we can't have a 5% from the beginning all the way from the service through the feeder, due to the branch circuit, all the way to the end load. We cannot have exceed 5% under the Energy Conservation Code, okay? International IECC. So if you do have that, go look at it. The 2001, the latest edition, go look at C405.10. It's entitled, I shouldn't say entitled, it's titled, it's titled voltage drop, and it's in there. And if this is an adopted application, then guess what? It speaks to requiring voltage drop. It is what it is. So while it doesn't apply to residential, it's a good recommendation. When it comes to commercial applications, it very much does require that you meet voltage drop applications. Okay. And again, this is a commercial, so it would be a building that falls underneath the scope of being a commercial building. Okay. So this could be where it doesn't apply to the individual dwelling units of a multifamily building, but it may apply to the general application of the whole building, which is a commercial aspect of it. It's going to be really what your jurisdiction is enforcing and how they are enforcing it. But it is in there. Now, is considering voltage drop something that people should take into consideration? I believe they should. Even whether it's residential, we have to be good stewards of the power. We have to be good stewards of the fact that equipment is now getting more and more sensitive to operate during a certain voltage range. There's a certain range that's optimized for equipment, and if it has a voltage stamped on the equipment, then there's a range. Typically, you can go 10% below or above. But again, the equipment offers a range. And as long as you're in that range, then you'd be fine. But since voltage drop is not a requirement anyway, for example, in a residential, so you can say, I like it within 10%, I like it within 5% of the voltage. That's up to you because there's no mandate for it. Now, at some point when voltage drop, if it ever does become a requirement in the National Electrical Code for other than sensitive electronic equipment or fire pumps, then we're going to have to break it down and explain why. And so a lot of people say, well, shouldn't it be that way for motors? Because if you don't give a motor the right voltage, it can overheat prematurely. Yes, but motors typically have an overload on it, and so that should kick in. Now, that doesn't mean it's going to be efficient. That doesn't mean that it's not going to prematurely heat up the motor in order to cause it to trip the overload? Yes, it might will be that way when you don't have voltages within the operating range of the equipment, like the motor. I get it. The question is it become a performance issue or a safety hazard? It's not a safety hazard if it have overloads in place, although you prematurely are going to be replacing motors that burn up because, again, they're operating outside of their voltage range, so they won't operate as efficiently. And so they'll overheat longer, stay heated, so the windings, everything might break down prematurely. It's not going to maybe not trip the overload, but it's going to prematurely wear out the motor. And so, the NEC is not a design manual. It's not a performance-based manual. Everything needs to be energy efficient. It's not really that. It's a safety standard. And so it's going to be hard to get something in the National Electrical Code to mandate voltage drop in areas where currently it's not at right now, which is the branch circuit, the feeder, and the service. The reason it's important for fire pumps is obviously, as we said earlier, a fire pump needs to operate within its voltage range. We don't need it to prematurely overheat. And since it's generally dealing with short circuit and ground fault protection, and overload is not considered because we do want the fire pump to burn up, right? We want to get people out of the building. So we don't want it to prematurely trip. So that is why they want to make sure they have enough voltage there so that it doesn't prematurely cause the motor to overheat. Well, that seems like that would also apply to all other motors, but that one is a little more safety driven because, again, we want to make sure that we can get people out of the building. So we want to make sure that we're not going to have an issue of it overheating because of a voltage issue, not getting enough voltage and not working within the parameters of that motor. I get it. It has a whole different use. And when it comes to sensitive electronic equipment, again, it depends on the type of equipment, and they're very sensitive, and they may be operating sensitive equipment that is vital to the infrastructure. And so that code panel with that submission to 647 have made the determination on voltage drop, and we just have to honor it. It is what it is. Anywhere else in the code, it's just right now a good recommendation that I think you should follow. Is it less important in residential to me as it is in obviously commercial, but it's still important nonetheless. So everybody needs to learn how to do voltage drop calculations, 2 times K times I times L divided by a circular mil, or the percentage, depending on what you're trying to find, the conductor or the circular mil, depending on what you're plugging in there. If it's 3-phase, you substitute the 2 for 1.732. It's pretty basic voltage drop calculations, and we teach this stuff in our courses and videos that I do, but you need to understand how to do it, and it's all very load dependent. Voltage drop is very load dependent. You have to know to do a voltage drop calculation properly, you have to know what the load is. If you've got no load, then there's no voltage drop because there's no load. The circuit's not going to be complete. It's just sitting there. So voltage drop is pointless if you're not pulling a load at the end. It's pointless. So when we do voltage drop calculations, we have to assume a certain load. And like if I'm doing it and I'm just assuming it's a 20 amp circuit, then I'm going to assume 20 amps at the end of that load because I could pull 20 amps. So that's what I'm figuring in. And when somebody asks me to do a voltage drop calculation, whether it's with Encore, Prismium, whoever it is that people contact me, I always say, all right, I need to know the distance one way. Okay, the K we already can figure out. We already got that. Whether it's 21.2 or 12.9, depending on whether you're using copper or aluminum, we got that. We can use the 2 for single phase, 1.732 for 3-phase. We got that. But I have to know what is the load at the end? What are the amps? What's being drawn? Because that's going to be a direct impactor on the voltage drop. And so it's important that we have all that information. So if I'm doing voltage drop and I'm making a consideration for voltage drop and I got to look at the circuit and I'm going to assume a full circuit unless you state otherwise. Now, I do have people that contact me that says, hey, Paul, I'm going to run this load at the end of 350 feet. And I'm like, okay. Well, the first thing you do is you have to size the circuit to protect the conductors. You have to size it. So if it is a 20 amp circuit and you have 12 gauge conductors, that's where you start. When it comes to voltage drop, you start, you know the conductor you're running to handle the load. Always do it to handle the load. And then you're protecting that conductor with the overcurrent protected device, and you size it like you normally would. And then you look at voltage drop. Because at the end of the day, you still have to protect the conductor at its ampacities, right? And that type of thing. So you have to do those things. But the voltage drop aspect of it is something that we look at after we already know that we've got the circuit taken care of. As long as I know I've got the right conductor and everything taken care of, at that point, I may have to increase the size of the conductors because of voltage drop, but I'm not doing it because of the load. The load is the load, okay? I've already figured that in to the equation. So I think a lot of people get that wrong and they don't understand the concepts of voltage drop. First things first, make sure you take care of the load. Make sure you size conductors, everything to handle the load first, to get that out of the way. Once that's out of the way, if you're going to take voltage drop into consideration, then and only then do you start introducing the conductor sizes and the percentages and start seeing whether that conductor is adequate enough. If it's not, you may have to bump up the conductor. It's still going to be fine. And can I have a larger conductor on an overcurrent device that say to have a 10 gauge and have it on a 20 amp device? As long as the device can handle it, take it, that's fine. That's not a problem. Could I splice from that 10 gauge back down to 12 to go to a breaker on the one end and then splice it to go back down to the other end? Absolutely I could, because we're doing it to accommodate voltage drop. Will I have to increase the size of the equipment grounded conductor proportional to the increased size of ungrounded conductors due to voltage drop? Absolutely. And that's pretty straightforward. We cover all that in 251.22b. It's a pretty easy process to do that. We talk about all that in 251.22. So, I mean, I think at the end of the day, you have to take voltage drop into consideration, even though the National Electrical Code is not going to mandate it on residential. Keeping in mind that the typical home is not going to make a difference. I would go out on a limb and say any home that is 4,000 square feet or less, it is not going to make a difference. It really isn't. Now, you start getting those 10,000 square foot, 12,000, 15,000 square foot homes, and you don't think about how you locate the panels. Again, it just makes sense to locate some panels centrally so I don't have to run these long home runs. Why? Because they could be damaged when the building finish is going up, the gypsum board, the trim, the mold. Damn, if I want to have some long home run stuck somewhere in the walls that I don't know where it could have been nailed through, I'd much rather have a feeder, one cable that I can be very paranoid about how I run it, to a panel that's centrally located to feed loads at that end. It reduces the voltage drop, right? But it also reduces the issues of these long home runs. I only have one long home run. You get what I'm saying? So it's all about design. And I think people today, like I saw in that Oklahoma house, why in the world that electrician would run home runs on that big ass house? I mean, I'm talking big house, folks. I'm talking 8-car, 10-car garage. I'm talking, it's just amazing house, beautiful house. But it had issues with AFCIs in it because I believe the home runs were too long. Plus, there was other things that they had to cut sheetrock out because of nails. Look, it's because they ran these freaking 12-2s and 14-2s and whatnot, 350 damn feet to get back to the panel, 250 feet, things like that. And I just think that it could have been designed much better. Okay, but that's me. That's just the design. That's the design guy in me. I just think they got a poor installation. So, do I want to do the investigation on the AFCIs or whatever? No, I don't. Unless they want to pay me to do it, and that wasn't what they hired me for. That's just something that I put out there to the manufacturers, and I go, I'm going to ask y'all a question. What is the maximum distance you can run with an AFCI and not potentially have issues? Is voltage drop ever an issue with these devices? Can that play a role? Why do you limit it to 50 and 70 feet under 210.12, but not for a combination? We're looking for series and parallels. You're not worried about distance on those, but is there a potential distance issue that we need to be aware of? So I don't know. I can't answer that for them. That's those manufacturers have to answer that question, and I haven't seen that answered anywhere. So anywho, all right, guys. Anyway, that's kind of a little discussion on my thoughts on voltage drop. And again, the International Energy Conservation Code seems to demand it, right? When it comes to commercial, doesn't really say anything when it's residential. The NEC only requires it for sensitive electronic equipment and fire pump applications where it is mandatory. Everywhere else, it's just really good information. A design professional, I would always take voltage drop into consideration just to make sure that I'm making sure that everything works within its voltage range. I don't want premature things like motors and air conditioning units. I don't want to have a Whirlpool hot tub, have an issue with the motor being so long up in a bedroom that's 190 feet away. And what is the voltage there? And did I take those loads into consideration? I get it. In the real world, we're just running cable, and we don't really take those things into account. But it's not required for residential. But move into commercial, and then we already have a requirement in C405.10 for voltage drop in the International Energy Code. So International Energy Conservation Code. So does your jurisdiction enforce that? Is that one of the adopted standards from your state that maybe your jurisdiction's choosing to look the other way? Maybe they don't even know the voltage drop requirement is in there. Maybe not. Who knows? Anyway, there you go, folks. Thanks for joining me. Hopefully you got something out of today's episode. Join us next time for another Master of the NEC podcast, and we'll catch you hopefully in the mornings on Coffee Hour. Join me 8 a.m. Monday through Friday on all of our social media platforms, as well as fasttrackstube.com. You can go watch under the live show link for free every morning, Monday through Friday, 8 a.m. Eastern Time. Love to catch you there. Bring your questions, bring your insights. Love to chat with you. Till next time, folks, stay safe. God bless.
Thanks for tuning into another electrifying episode of the Master of the NEC podcast. We hope you're feeling more powered up and ready to tackle the electrical world with the knowledge and confidence you need to succeed. Remember, in the electrical trade, knowledge is power, and we're here to make sure you stay plugged into the latest insights, tips, and code updates. If you enjoyed today's episode, don't forget to subscribe, leave us a review, and share the podcast with your fellow electricians and industry pros. Until next time, keep your tools sharp, your circuits clear, and your mind focused, because here at the Master of the NEC podcast, we're all about sparking your success. Stay safe, stay smart, and keep mastering the trade. From all of us here at Electrical Code Academy, thank you for all your support, and we will see you on the next amazing Master of the NEC podcast episode.